In today's class, we will discuss about the inductance of three-phase lines. So there are three derivations under this three-phase line inductance calculations. One is, the first derivation is three-phase line with equilateral or symmetrical spacing, and the second derivation for three-phase inductance calculation is three-phase line with unsymmetrical spacing, untransposed line, and the third derivation is unsymmetrical spacing, transposed line. So the first derivation, inductance of three-phase line with equilateral or symmetrical spacing. So any three-phase transmission line can be called as symmetrical when the conductors are situated at the corners of an equilateral triangle. So if the spacing between the three conductors are equal, we call it a symmetrically spaced three-phase line. So conductor three-phase transmission line with symmetrical or equilateral spacing arrangement is shown below. So A, B and C are the three conductors, and we take the symmetrical spacing, equal spacing between the conductors as capital D. You can see the distance between A and B is D, B and C is D, C and A is also D. So let the radius of the conductors be small r. So let IA, IB and IC be the currents through the three conductors A, B, C respectively. So for a balanced three-phase system, the sum of the three currents will be equal to 0. IA plus IB plus IC will be equal to 0. So in the previous class, we have already derived the flux linkage of any conductor in a group of n conductors. Okay. So that general expression we obtained as psi n is equal to 2 into 10 to the power minus 7 summation p equals 1 to n ip into ln 1 by dnp. Okay. So now using this generalized expression, we are going to write the equations for the flux linkage of conductor A due to the three currents IA, IB, IC, flux linkage of conductor B due to the three currents IA, IB, IC, and flux linkage of conductor C due to the three currents IA, IB and IC. So first we will take the flux linkage of conductor A due to the currents IA, IB, IC. Okay. So instead of N, we write it as A, the first conductor. So IA is equal to 2 into 10 to the power minus 7. So now what is your P? P is equal to A, B, C. P is equal to A, B, C. Okay. So IA, now P is equal to A. First term is for P is equal to A. IA ln 1 by D A. Okay. So what is P? P is A. N is the conductor A. Okay. So DAA plus, now P is second term is for P is equal to B. IB ln 1 by D AB. It's the flux linkage of conductor A. Okay. So 1 by DAB. Third term P is equal to C and conductor is A. So IC ln 1 by DAC or DCA. Okay. So now we know DAA, it is nothing but the geometric mean radius of conductor A. Okay. So DAA is equal to R dash, which is R into e to the power minus 1 by 4. So in the previous derivation, we have replaced R dash by, we got actually the first term as R dash. So we wrote it as D11. Okay. So in the same way here, DAA is nothing but its own geometric mean radius. Okay. So DAA is equal to R into e to the power minus 1 by 4. And DAB and DCA are equal to D. So do the substitution for this. You will get psi A is equal to 2 into 10 to the power minus 7 IA ln 1 by R dash plus IB ln 1 by D plus IC ln 1 by D. So now ln 1 by D is common. So we can take ln 1 by D outside. So now psi A is equal to 2 into 10 to the power minus 7 IA ln 1 by R dash plus IB plus IC into ln 1 by D. So we know IA plus IB plus IC is equal to 0. So IB plus IC will be equal to minus IA. So substitute IB plus IC as minus IA. So psi A is 2 into 10 to the power minus 7. IA ln 1 by R dash minus IA ln 1 by D. So now again we have IA and IA. Okay. So this minus IA can be changed to plus IA if you take this denominator inside the logarithm to the numerator. So minus IA ln 1 by D is nothing but plus IA ln D. Okay. So then we can combine both the terms. So 2 into 10 to the power minus 7 IA ln D by R dash Weber turns per meter. So flux linkage of conductor A due to all the three currents is calculated. So now we write the inductance of conductor A. Inductance of conductor A is LA is equal to psi A by IA, which is 2 into 10 to the power minus 7 ln D by R dash Henry per meter. Okay. So this is the inductance of conductor A. So in the same way, we derive the flux linkage of conductor B due to the three currents. Okay. So psi B. So now your conductor number N is B. Okay. And P is equal to A, B, C. Okay. So now 2 into 10 to the power minus 7. The first term. First term is for P is equal to A. And the conductor is B. Okay. So IP. Okay. So IA ln 1 by D NP DBA or DAB plus the second term. For second term P is equal to B. IB ln 1 by DBB plus for the third term P is equal to C. IC ln 1 by DBC. Okay. So now we know DAB is D. DBC is also capital D. DBB is R dash. So do that substitutions. You will get psi B as 2 into 10 to the power minus 7 IA ln 1 by D plus IB ln 1 by R dash plus IC ln 1 by D. So now again you can take IA plus IC as minus IB. Okay. So 2 into 10 to the power minus 7 minus IB ln 1 by D plus IB ln 1 by R dash. Now these two terms can be combined as psi B is equal to 2 into 10 to the power minus 7 IB ln D by R dash. Okay. So after calculating the flux linkage of conductor B, the inductance of conductor B is LB is equal to psi B by IB, which is 2 into 10 to the power minus 7 ln D by R dash. Okay. So we have seen LA is also 2 into 10 to the power minus 7 ln D by R dash. LB is also 2 into 10 to the power minus 7 ln D by R dash. So we can write in a similar way. Inductance of conductor C is LC is equal to 2 into 10 to the power minus 7 ln D by R dash Henry per meter. Okay. So for a three-phase transmission line with equivalent or with symmetrical spacing, the inductance of all the three conductors will be the same. LA equal to LB equal to LC equal to 2 into 10 to the power minus 7 ln D by R dash.